Hi there. My name is Damian Thorn-Hauswirth. I'm a professor at East Stroudsburg University, and I find that students can be intimidated by Houdini, even experienced 3D artists can find it challenging. So this is a very introductory level tutorial where we will be making this motion graphic lava lamp type effect. Let's get into it. All right, so here we are in Houdini, and I'm looking at the node setup to create this sort of effect. And at its core, it's pretty simple. Basically, we're taking some points and scattering them around. We're copying a sphere to these points, and then we're leveraging some VDB tools to smooth out those spheres and create that sort of fluidy, lava-y effect on this. And so this is a lot easier or controllable than trying to set this up with a fluid simulation, which would be a totally valid way of going about it, especially if you needed very realistic physically based results. But this is a nice, fast way of making something similar here. So let's just go ahead and recreate this off to the side here. So you just need to start off with some points. So one way of going about that is using an add node, which just can create a point. So I'll just press the plus sign here. And now we have a single point right here at the origin. I used a point replicate here to then duplicate that point. So I can lay down a point replicate. And that'll just create a lot of points based off the position of that first point. You can look at these options to create different shapes. Maybe I'll try something different here and do a cylinder and make this a little more tall, maybe a little more like a lava lamp for this example. All right, so now I have a bunch of points, and really I just want to copy some spheres to these points. So I can use a copy to points node to do this, and I will also lay down a sphere node. And the first input of this is the geometry that you want to copy. So I'll plug in my sphere to that first input. I'll just rearrange this so the wires are a little bit more clear. And then this second input is the points you want to copy that geometry to. And if I put my visibility flag on the copy to points, now we have a bunch of spheres copied to the points. I could go ahead and lower the uniform scale of my spheres, and you can see I have those spheres being copied. Now I want to think about adding some variation to those spheres, which is what all of these nodes are doing right here. So I'm varying, in my example, the color, the p-scale, and the position. So let's go ahead and try some of that out. So to vary all these attributes, so Houdini is really built upon attributes, and p-scale and color are attributes you can mess with. I can start typing in ATTR for attribute, and then I can start typing adjust, and all of these are nodes that lets you adjust attributes. So I'm going to do attribute adjust color and just plug it into the points. And by default, when you're copying to points, this source geometry is going to inherit the color and p-scale of these points. So on my adjust color, instead of having the operation to set, instead of having the pattern type to constant, I'm going to switch that over to noise. And you can see this automatically gives it this kind of rainbow visualizer, and we can see each point is getting a different color here based on this color ramp. You could use one of these other presets by clicking the gear. Maybe I'll try sand just for fun. And now if I preview my copy to points, you can see we have this sandy color. Maybe I'll do more of like a, let's try twilight. I'll go with that one. This is up to your artistic discretion. And I'm also wanting to vary the scale, so I'll put another attribute adjust. And so p-scale is just a single value, which is a float. So I'll put down attribute adjust float, stick that in my chain. And by default, this node is already set to p-scale. And I want to do something similar where I change this to a noise. And you can see now we're getting a bunch of different sizes for the spheres. I can adjust the minimum and the maximum values of this, and this will have a big effect on how our lava looks. If I wanted like more small ones, I could adjust this custom ramp. we could adjust the element size, which is the frequency of the noise. So that's how fast you'll see this changing across your geometry. Let's say I'm fine with that. We can always go back and adjust that. Now we want this to sort of float around a bit. So I'm going to use another attribute adjust node. So I'm going to go attribute adjust vector, which is basically the same as color. Color is just an attribute adjust vector sort of preset for color. And instead of having my vector adjust v, which is velocity, I'm just going to change that to p for position. So position is a vector, which means it has 3 values, x, y, and z. We want to adjust all of those values with some noise. So I'm going to do it once again. I'm going to adjust with noise. And so this noise by default is set to positive, which means it's sort of going up and to the right, just to positive values. I'm going to set this to 0 centered, so these points get pushed around every which way. And I'm going to go down here and click animate noise. So now when I hit the play button, these spheres start flying around. So if you need like insects swarming or something like that, you got that effect for free. I'm going to go ahead and slow this down by actually increasing this pulse duration. And now we have more of a smooth kind of fluid movement. I could even type in a higher value if I wanted this to be even slower. I could mess with the element size to get different looks to the movement. But let's say I'm fine with that for now. All right, so that's sort of the part 1 of the setup. I'm making spheres, adjusting some attributes on the points to vary them, and now I want to think about adding that sort of lava-like effect. So in order to do that, we're going to leverage some of Houdini's VDB tools, which are amazing. So not many software, if any, has as robust of a VDB workflow as Houdini. So I'm going to cut here and just explain a couple things about VDBs. Okay, I want to take a quick segue here and talk about VDBs and SDFs. So a VDB is just a data type that can hold volumetric data, or voxels. So if you've ever played Minecraft and you have all these little 3D cubes, that's how you can think of voxels. And you can see here, if I increase my voxel size, this starts looking like a bunch of cubes that are stacked on top of each other. So voxels are little 3D cubes, and they're used to represent volumes. And VDB is a data type that can store that data. So you can save out like a .vdb, which would just be like the same as a .jpeg or .png for images, but this is a data type to store volumes. Now, Houdini has 2 types of VDBs, surface and density. So density, or fog VDB, if I click that on, you can see that's used for things like smoke and clouds, and it has like this fluffy volumetric look. That's pretty straightforward. The other VDB type is what's known as an SDF, which is right here when you check distance VDB surface. This is now an SDF. So what is an SDF? Well, SDFs are a signed distance field. So this is a way of representing the surface of an object through voxels. So essentially what you have here is at the surface of an object, the value of that would be 0, and then anything inside the object, it would be a negative value, and anything outside the object would be a positive value. So that's where this name comes from. Signed, it's either plus or minus. Distance, it represents the distance to the surface of an object. And field is just a lot of arbitrary points in space. Any point in space, to be exact. So this is quite useful. This is going to make sense in a second how powerful this is, because it's really an amazing thing you can do. But just to kind of elaborate on this a little more, let's say like you have like an arbitrary, some arbitrary points. I'm going to illustrate here. All of these points that are outside this sphere, the surface of the sphere, these would be positive values. So let's say like this point is like 1 unit away from the sphere, then that would have a value of 1. let's say this one is like 0.4 units away, that would be 0.4. And let's say like this one is inside the sphere, then that would be negative 0.4, some negative value. And if you had a point right on the surface, that would be 0. Keep in mind, this is sort of like a 2D representation, but this would all live in 3D space. Let's look at one other illustration of that back in Houdini. So I'm going to put away my drawing tablet here. And let's take a look at this little example here. So if I have a sphere here and I use a convert VDB node and check it to distance VDB, I now have an SDF, right? I can middle mouse and I have that surface VDB and I have 13,846 voxels there. I can change the voxel size and you can see I'll get basically like just a few cubes if I go really high up with this. As I make this lower and more high resolution, we'll get a nice smooth surface representation of that sphere. And then I can convert that back to a mesh after that. So I can go from mesh to VDB, which if I click wireframe, we just see these cubes. And then I can convert back to a mesh here. If I were to visualize this another way, if I make a grid, and I'm going to template this sphere by hitting this little pink template icon, this grid is cutting right through the center of the sphere, and I scatter some points on this grid. I could use a point VOP. I'm not going to get into how to use VOPs for this tutorial, but just know that I'm using this node to visualize this. And I'm basically coloring these points based on their SDF value. Anything red is being negative, white is 0 right at the surface, and anything green is outside this sphere surface. And I can adjust this ramp to get different fall-offs of that. And this can be very, very powerful. Let's jump back to the main tutorial here and see how we use that. And now I'm cutting back to myself. So now we're going to change all of these polygonal spheres into SDFs. So to do that, we can do a VDB convert. Sorry, misspoke. We can use a VDB from polygons. We will be using a VDB convert in a second here. VDB from polygons. And this allows us to change a geometry to a VDB. So I'll just plug that into the first slot, change my visibility flag, and now we have that blocky looking SDF. If I uncheck that and change it to density, now we have this smoky visual. But for us, we're going to use SDF. And really what this allows us to do, one really cool thing about SDFs, you can almost think of this as like a super Boolean operation. We can take geometry and almost Boolean it together and adjust how those geometry interlock and kind of blend with each other. This is really great, even if for like 3D printing. If you have like messy geometry, you could turn it into a VDB, then turn it back to geometry and have a watertight mesh for 3D printing. So I'm going to lower my voxel size a bit so we get more detail to our spheres. And now we have pretty much the same thing as the spheres, and it just looks a little blocky. Okay, big whoop. But what you start to see is that we have almost like a continuous look between our intersecting spheres. And to really massage this, we can use some of the smoothing operations. So I can go VDB smooth SDF and plug that in. Whoops. Plug it into just the first slot. Put my visibility flag there. And you can see immediately these spheres start to sort of blend in with each other. And maybe I'll go back up and adjust my P scale just to get some bigger spheres so we can start really seeing this. And I'm going to kind of mess with some things. And so now I have some smaller spheres joining and some bigger spheres joining. In my example, I messed with the operations of this a little bit. So you can kind of tweak this to your heart heart's content, but I tried Gaussian, which gives you a more aggressive smoothing. I combined that with mean curvature flow, which is less aggressive and it respects sort of the curvature a little more. So this is something you can play with, and you can see if you go too far, you'll start losing some spheres, and you might have to start lowering your voxel size a little bit to get that data back. So I'm going to go ahead and do that. I'm going to use 1 with mean curvature flow. I'll up the iterations, which just increases the smoothing. And then I'll chain another one. And this is where you can get creative and play around with this to get different effects. And I'll try to do a more aggressive Gaussian blur here. So now we're getting sort of this pulling between spheres that intersect. And I can kind of scrub my timeline and get an idea of what's happening. So we'll get all this sort of interesting smoothing and blobbiness start to occur. So now this is still an SDF. If we want to get it back to geometry, I can just now put down that convert VDB node, plug that in, and I can convert that back to polygons. And now we have polygons. You don't really have to mess around with these values too much, but just know this ISO value is essentially inflating and deflating the geometry based on the SDF value. So if you needed to tweak that, you could to get some different results. But by default, I'll just leave it at 0, which is creating that polygonal mesh right at the surface where those values were 0. Now you'll notice the one thing we're missing here is the color that we had established back up here at the top. So to get the color back, we can use something called an attribute transfer, which is probably the easiest way. There's always a million ways to do anything in any software, but this is a good beginner-friendly way of doing it. I can put down my attribute transfer, and I can wire in my converted VDB to the left slot there, and then on the right slot, I'm going to wire in the geometry where I have the source data that I want to transfer. So in that case, that is right here on my copy to points node. I can wire that into the second input, and you see by default we get this sort of blocky looking transfer. If I wanted to be explicit about this, I could uncheck primitives and then just specify I'm only transferring CD, but by default it does them all your attributes there. And I could play around with the distance threshold here. This won't make too much of a difference since the meshes are so close together. If I template my source geometry, they're basically right on top of each other. But what I do want to do is kind of smooth out these transitions. So I can do that with an attribute blur. By default, this is set to P for position, but I'm going to just change that to CD. So I'm going to blur my CD, and if I up my blurring iterations quite a bit, you can see I get that nice soft gradient between colors. And now I have my lava lamp set up. So you can see here, I can just scroll through the timeline and see that effect. I could go back up to my attribute adjust color and try out some different color schemes for this. Let's try, oh, that's kind of an interesting one. You can adjust your P scales here to get some different results. You could get the shape of your point replicate and play around with that to get some different visuals. You could adjust the number of points you're scattering in here. You could even go wild and, you know, try to scatter some other geometry besides the sphere. I could maybe make a subdivided pig head. This might get pretty insane, but let's just throw caution to the wind. I'm going to make this a little smaller to match the size of the sphere. Throw that into my copy to points and lava lampify that. Now I have this blobby pig head getting combined. You could vary the rotations on that and really start messing with it, but you get the idea. That's the power of Houdini. You're building this little machine, and then you can really play with it like you're in a sandbox and make some interesting visuals. Now, let's just do a quick sort of coverage of how I rendered this. So if I jump over to the stage context here, there's nothing too fancy going on, but I'll just point this out. I do have kind of an intro to rendering tutorial. I'll link somewhere up in the video, but I'm going about this pretty simply, where I'm using a scene import node, which literally just imports everything you have in your object context to the stage. The stage is also known as Solaris. This is where we set up materials and lighting and camera in Houdini. And the scene import simply takes everything from this object context and transfers it over to the stage world. And then I'm using a material library, which is basically a folder that holds all your materials. If I double click on this, I just have one material called lava, and that is made using the Karma material builder. I'll double click on that to show you what's going on. All I'm doing here is I'm using the material X geometry color. If I just type material X GEOM for geometry, material X geometry color comes up, and that's just a quick way of bringing in that color value into your material. And all I'm doing is linking up that geometry color to my base color and my subsurface color and radius. So I'm relying a lot on subsurface for this render. You could really play around with this to get a ton of different effects. And I'm applying that material just by indicating I'm applying lava to the lava lamp. And then I just have a single light here pointed up from the bottom. I use the Karma fog box to create a little fog volume. I'll just start a render preview here. And so we get this kind of nice atmospheric look going on with the God ray effect. And then I'm just adding a camera and some depth of field and rendering it. So it's just that single light, single material with a nice foggy look. And you could have a lot of fun customizing your materials and lightings to get different effects. If I turned off subsurface, for example, and I turn this to metal, we would start getting a totally different look to this. It's just updating my render right here, so that takes a second. So now we have more of a metal, almost like painted metal look to our spheres. I could adjust all of these lighting scenarios. Maybe I bypass that, put down a Karma physical sky to get a totally different look. Let's see how that ends up working. All right, so now we have a totally different look to our render. I could go ahead and uncheck render light geometry and press D and uncheck display environment lights as background just to see just my blobby stuff. And it's a totally different look. I could kind of scroll through the timeline, get some different rendered. We get a little nice pulling on that one. Could go back to the material library, adjust some of these. Maybe I just try all like a metal look. There's your like what was the show where the Alex Mack metal look, or Terminator look, I guess would be a better relatable reference. But there you go. That's a very simple setup that you could adapt and create some interesting visuals with. And really at the basis, we're using some of the foundational workflows in Houdini, where we're looking at attributes and varying those to create different looks. And then the whole materials and lighting process is very similar to any other 3D package you have. Hope you enjoyed this. Let me know if it was helpful, if you want to see more sort of beginner content like this. And I hope you have a great day. Bye-bye.